Okay, welcome back. So, in the first video of this unit, we talked about different lines that intersect the circle. So, in this video, we're going to be talking about arcs and chords in particular. So, when we look at a circle, for example, again, I draw a circle. I have my center of my circle, which we're going to call O. If I sketch two radii from the center of the circle to the circle itself, these points, we're going to call this A and we're going to call this B. The angle that is formed here is referred to as a central angle. So a central angle is an angle where the vertex is the center of the circle. Okay? Okay. Now, with that said, so we have angle AOB, which has O as the center as the vertex. The part of the circle that falls between A and B is what we refer to as an arc. So this segment, this part of the circle here that falls between these 2 points is what we refer to as an arc. Now, with that said, we have what are 2 types of arcs. So if I draw a circle, and let's say I do my center O, and this time we have C and D, okay? So this part here, anything that falls between C and D itself, and we're going to have this point, we'll call this E over here. So keep in mind that the central angle is angle COD. This arc itself, this arc, what we call CD, is what we refer to as a minor arc. So a minor arc is an arc whose points are in the interior of the central angle. Okay? Now, this other part, this arc CED that falls outside, is what we refer to as a major arc. Again, it helps like spell. So a major arc is an arc whose points are on or in the exterior of the central angle. Okay? Now, with that said, when we name an arc, depending on what we're looking at, minor arcs are usually labeled with the 2 endpoints. Major arcs are usually labeled with 3 points. So in this case, the minor arc, we would call this arc CD. And if we use a symbol to designate an arc, we would write it like this. So arc CD is what we consider the minor arc. Okay? Now, one thing about minor arcs, or any arc measure for that matter, are measured in degrees, representing the degrees of the circle. So in this case, this minor arc, CD, is the same as the measure of the angle COD. So we put the M in front of it, so we can say that the measure of arc CD is equal to the measure of angle COD. So for example, if the measure of angle COD was 120 degrees, then we can say that the measure of arc CD is equal to 120 degrees. Okay, now for the major arc. So with the major arc, we would call this arc CED using the 3 points. And again, we would designate that as arc CED like this. Okay. Now, what if I wanted to find the measure of arc CED? Well, we could do that. We know that this part of the circle is 120. We know that the whole circle is 360. So to find the measure of arc CED, we would do 360 minus 120 to get a total of 240 degrees. Okay. Now, one thing real quick. With that said, if I have my center, we'll call this O, and we have our point FG. Notice that this is the diameter of a circle. And remember, the diameter cuts the circle in half. So when I cut the circle in half, that forms a semicircle. So a semicircle is an arc with endpoints on the diameter. So a semicircle is an arc with endpoints on the diameter. So we can say that the measure, and I'm just going to put a random point FGH here. So we can say that the measure of arc FGH, when we include the M in front of it, would be equal to 180 degrees. Okay. So, with that said, arcs can be added together just like angles. So we also have what's called the arc addition postulate. So the arc addition postulate says that if I have a circle, let's say I have this random point L, M, N, okay? Notice that we have arc LMN. So the measure of arc LMN, the whole thing, is equal to the two parts. So it'd be equal to the measure of arc LM plus the measure of arc MN. Okay, so in this example, let's say I give you this picture. and I tell you that measure, and we'll call this center O. So the measure of angle LOM is, let's say, 65 degrees, and the measure of MON is 60 degrees. They'll say, find the measure of arc LMN. Okay, great. So we go back to the idea of, since these are central angles, we know that if this is 65 degrees, the measure of arc LM also has to be 65 degrees. And if the measure of angle MON is 60 degrees, we know the measure of arc MN has to be equal to 60. So now that we know the measure of these arcs, so we know this arc is 65 degrees, we know this arc is 60 degrees, and that's because of these central angles, we can say that the measure of arc LMN from up here would be equal to 65 plus 60, which gives us 125 degrees. Okay. Now, with that said, just a few things that pop up. In a circle, so in my circle, for example, let's say I have my point O and I have R, S, T. Okay? Now, let's say that these two angles are congruent. So if angle ROS is congruent to angle SOT, if those two angles are congruent, we can say that the chords between RS and ST are also congruent. So if angle ROS is congruent to angle SOT, then the chords, so segment RS, is congruent to segment ST. Now, if we expand on that, since these angles are congruent and these chords are congruent, that means that the arcs are congruent. So we can say that if segment RS is congruent to segment ST, if the two chords are congruent, then the two arcs are congruent. So then we can say that arc RS is congruent to arc ST. And then last but not least, now we can say that congruent arcs have congruent central angles. Congruent arcs have congruent central angles. So if I can show that arc RS is congruent to arc ST, then we can say that angle ROS is congruent to angle SOT. It's the big deal. Okay. All right. Last but not least here. And again, if I have a circle, let's say I have a point O, let's say I have a point A, I sketch in that radius. Let's say I sketch in a chord. We'll call this YZ. Okay? Now here, the big deal is that these have to be perpendicular. So we have a theorem that says that if a radius is perpendicular to a chord of a circle, then it bisects the chord and its arc. So here, what we can say is that if OA is perpendicular to YZ, then we can say that OA bisects YZ, which would make these two congruent, and therefore that would make these two arcs. Okay. Also, with that said, we can say also that the perpendicular bisector of a chord is the radius of the circle. So we can say that the perpendicular bisector of the chord is the radius of the circle. Okay, so an example of where we can see that potentially be applied would be if I were to give you a circle. Here we have point A, we have E, and we have BE, and we'll call this C. And I tell you that these are a right angle. This is 2, this is 3. And the question says find the length of BD. Okay, so they want me to find this entire chord. Okay, well, to do that, if this is a perpendicular bisector, I only have to find one part. If I find the one part, I can double it to get the whole thing. So what I'm going to do is, because I know this is a right angle, I'm going to sketch in the radius from A to D. Now, why would I do that? Well, the reason why I would do that is because I know that the length of this radius is 2 plus 3, which is 5. And remember that all the radii of a circle are the same length. So if this is 5, that makes this 5. And by sketching this in, ooh, look, I have a right triangle. So I'm going to use the good old Pythagorean theorem here to help me answer this question. So I'm going to use a squared plus b squared equals c squared. This is our hypotenuse. This is our c. This is the side. So that we're going to call that a. So we have 3 squared plus b squared is equal to 5 squared. Go ahead and solve the equation. So 9 plus b squared equals 25. Subtract 9 to get 16. Then we take the square root, and we get b is equal to 4. Wonderful. That's this. If this is 4, because this is a perpendicular bisector, that means that this has to be 4 also. So now we can find that the length of BD would be 4 plus 4, which gives us 8. All right. So I'm going to go ahead and stop here. You may be potentially asked to answer some questions using what we know about arcs and chords. As always, if you have any questions, do feel free to reach out to Mr. Ard or myself. You can send us an email and ask your questions there, or you can send us an email asking for Google. Have a great day, and we'll talk to you later.